What I'm going to be demonstrating here is how you would go about walking into a rice field and then scouting for rice water weevil damage, and then to assess pruning of the rice water weevil larvae feeding on the roots. So this field is a field of rice that was not treated with any insecticide for rice water weevil management. It's been about 4 weeks since application of permanent flood. So this is a situation where you could come in and assess the damage that's been done. At this point, you couldn't really do anything else about management, unfortunately, but you could possibly consider draining the field and then reapplying a flood. What you'll see here is these white stripes that are along the length of the leaves, so they run longitudinally with the veins of the leaf, and some of them actually are even all the way fed to where there's nothing present there anymore. And these feeding scars are caused by the rice water weevil adults when they're feeding on the leaf before they actually mate and then go down right below the surface of the water here and lay their eggs inside of this leaf sheath. The larvae are then going to hatch out of that egg and go down and burrow through the mud, and then we'll pull a sample here to show you what happens. So you can see that the root mass here is pruned. There's a few longer roots. Ideally on the plant, all the roots would be, or most of the roots would be this length, as opposed to being clipped like they are. And this damage has actually been caused by the rice water weevil larvae feeding on the roots. So if you wanted to assess the population of rice water weevil larvae in your field for yourself, what we do in our experimental studies is we use what's called a core sampler. This takes a consistent volume of soil. Most of the rice entomologists throughout the U.S. use the same core sampler, so we're able to compare samples across fields. The way that you'll take a core sample is grab about a handful of plant material here that wouldn't be too wide to fit inside the diameter of this core. And then come down, push down in the soil until it breaks the soil surface and it comes. The core sampler itself, the top of it is going to be about flush with the soil line. And then you pull up this plant with the dirt and the root mass. This is the volume of soil, and then you have soil here associated with the roots, and what you would have inside of here would be the rice water weevil larvae feeding on the roots if they're present in this field. What we normally do is take this back to the station and process it, but if you want to do this in your own field, you can just use a bucket sampler. You'll take the dirt off of the roots here in the bucket. Just vigorously wash off the roots. Separate the plants to make sure that you're really getting all the dirt off the roots. And then you have to work on the clumps of mud that are down in the bottom here. And you'd want to go to a part of the field where you have a little bit cleaner water to help to observe these things. So I just disturbed the water there. Put it down in the water and look for larvae to float up. And so what I'm seeing is a white grub with a little bit of a light brown head capsule. You can see it there. Just quickly here, I've seen 3 or possibly 4 larvae. So at this stage of growth, these larvae are getting pretty close to their the most mature instars, and then they will make a little mud pupae. They'll take some mud near the base of that plant and they'll make a pupae around themselves, and then they'll emerge as adults. And then they might move to another nearby rice field that is behind this field, but they will typically not reinfest the field that they've already been in, because the plant is to a stage of growth that's no longer attractive to the larvae or to the adults for laying eggs, and then for the larvae to mature on those plants. So they could move into a neighboring field, or they might just move back into these overwintering habitats in the bayou, for instance here, and wait for the spring to come back in and reinfest this field in the spring, or to infest another field. So this is a broken off root tip right here, completely smooth. What allows you to know that you have a larvae is, well, they'll be wriggling around. But they also have a segmented body, it's white. Sometimes when they're a larger stage, you can see what's called the spiracles, which is their ability to conduct air along the length of the body. So now I'd like to go ahead and show you a field that's just across this levee here that actually was planted with Dermacore X100 treated seed. And we shouldn't really find any larvae in there. If we do, we should only maybe find 1 or 2 by comparison to what we found here. And just in our quick assessment here, we found 5 larvae. If you go based on the estimates that 1 larvae would cause half to 1% yield loss, we could have anywhere from 2.5% to 5% yield loss to that 1 plant. What we've done is moved over to the field that actually did receive the Dermacore seed treatment. This was planted at a 65 pounds per acre seeding rate, and the Dermacore was applied by the certified treater at that proper rate for a 65 pound per acre seeding rate. And what I'm going to do here is take a core sample off of this plant So as I said before, the core sample you drop the core sampler down until the surface, the top of that rim is just about level with the surface of the soil line. Pull it out and put it in the bucket. And then we will vigorously wash this in the water. So you can see here that we have a substantially larger amount of root mass than we had in a lot of nice white growing roots than we had over in the field that did not receive the Dermacore treatment or any sort of insecticide treatment at all, the completely untreated field. There's a little bit of some smaller roots here, but for the most part you have a really nice root mass that's going to support this plant as it continues to grow and then put on some weight when it starts to mature grains. So to finish washing this, we'll break up these mud clumps that are down at the bottom. Now I have a lot of muddy water in here, and to clear it up a little bit so that I can find the larvae floating on the surface of the water, I'm going to move to a part of the field where I have some clear water and it's a little bit deeper, and there's a little drain in the field here, so that works well for that. The larvae should float to the top if they're present in this sample. When we do process these samples at the rice research station, we use a saltwater solution, and that helps the larvae to float to the surface of the water better than they do in the field. Just watch this for a little bit, see if anything comes up. By this time, when we had washed the roots into the bucket sampler in the untreated field, we had seen 4 or 5 larvae float to the surface of the water, and we're not seeing that happen here, which is what we would expect to see with the Dermacore treatment on the seed. The way that the Dermacore insecticide works is it actually kills the larvae when they start to feed on the roots, so they don't have the chance to go through their development to the adult stage and then cause the pruning to the roots while they're doing that. So hopefully now you'd be familiar enough to scout for rice water weevils in your field and then make the assessment of whether or not you need to make a treatment for control of the adults before they have the chance to lay eggs. Or if you did treat your field with the Dermacore seed treatment, you could go in and look to make sure that the insecticide treatment actually worked to prevent a rice water weevil infestation of your field. You can contact your local parish office or your county agent to get more information on rice water weevil management and more training on scouting.